Hello there, and a very good evening to everybody here. I'm Alan, the chairman of the wonderful Hertford Astronomy Group, and it's my pleasure to welcome you to this meeting. If you're a new person here, and I know we've got one or two people, can I just ask you, have a little look around the room and you can see some people waving their hands around. Have a little look. Right. Now, please make sure before you go home today, you go and have a word with one of those people just to say, yeah, I'm new here, I enjoyed it, or have you thought about this or that or the other? But we want to make you feel very welcome. Okay, just a few of the usual housekeeping things to go through for those of you in the university. If the fire alarm goes off, we're not expecting it to be a practice, so please exit safely through the emergency exits. Gather on the car park where we will check everybody is safe and sound. Can I also ask if you've got any electrical devices such as phones, fitness things, anything that makes a noise, could you switch it off please so it doesn't disturb the meeting? And of course, if you haven't found them already and need to, toilets are just through the door outside that way there. And a very good evening to everybody who's on Zoom. It's lovely to see you here as well. If you're new on Zoom, wave. We can't see you, but we hope you feel better about it. One person waved. Two. Any more? Any advance on two? Okay, well, it's lovely to see you here as well. All we ask for the people on Zoom, if you could keep your fingers away from the space bar, otherwise you might join in the meeting with something inappropriate. The format of the meeting, we've got a slightly different one tonight, but we're going to start off the same. John Fraser's going to give us a wonderful talk about the night sky. And then we're going to hand over to Jerry, who's going to introduce tonight's speaker, Garry Hunt. And of course, that's going to be on Zoom tonight. So you'll be able to see what's happening there. You'll be able to ask questions at the end of it. And for those of you on Zoom, if you've got some questions to send down, put them in the chat box and we'll make sure they get read out. So after we've had Gary's talk, I will have a few closing remarks about meetings coming up, and we will hope to finish around about 9:30, 9:45. So, no more from me, it's over to John.
Hello. Okay, so I'm going to take you through the night sky news. I've had quite a busy month, so this is going to be shorter than usual, which I'm sure everyone's pleased about, especially these guys. They've left a clock here to remind me how long I've been talking for. I like a gentle hint. Okay, so the moon, currently we're in the third quarter. It is going to be full just before the next meeting. Not a lot going on. Around the 4th of December it crosses the Pleiades, which is always nice to see. Richard at the back there, he did a quite nice GIF, I think it was earlier this year, of the time last time the moon went across. You can see the stars getting occulted out of the way. Lasts about 2 hours. Unfortunately, this is going to happen between about 3 and 5 a.m. on the date, so one for the hardcore. All right, and we've got it about 3 degrees away from Saturn. If anyone's wondering what 3 degrees is, it's roughly 2 fingers held out at arm's length. Okay, Comet Lemon. Now, this is an optimistic picture, and there's a image, and there's a reason I put it in there. Comet Lemon is theoretically still in our skies. Is very low, lost in the twilight, magnitude 11, which is very dim, and it hit perihelion, I think, on the 4th or the 8th of the month. So moving away from the sun, just getting dimmer as the month goes on. I put in here because Richard actually gave me this picture he took a few weeks ago. This was while it was still in booties. Apparently Arcturus is in this image, but I am nowhere near good enough an astronomer to tell you which star that is. But it's a really great image. It comes round about once every, well, it has been coming around about once every 1,400 years, 1,500 years. It's because of this route, it's coming back 200 years quicker. I think it's 1,350 years till it comes back. So you've missed your opportunity, I'm afraid. All right, what's happening with the planets? Mars is pretty much a no-show. It is lost in the sun. This image of Mercury and Venus. Venus is very bright, just about -4 magnitude, stunning morning star, easy to see even in the brightness of the sky. Mercury, not so much. You'll struggle to see it at first. They're actually going in opposite directions. So Venus is heading this way. Mercury's going to head towards the right-hand side of Libra until about the 30th of November, and it'll start heading back. So there's a chance to see it. I would say, usual precautions, do not try to look at Mercury once the sun is in the sky, because you probably won't ever see it again if you do. Jupiter is hanging around Gemini, and it's not really moving very much. It's starting to go into retrograde, so it's going to start heading westward shortly. It comes up about 9 o'clock, very bright, magnitude -2.5. I saw it 2 or 3 nights ago on the way back from London. Even though it was fairly close to the moon, it was absolutely beautiful. Well worth seeing. Saturn and Neptune, as I said, 3-degree difference there between Saturn and the moon. It's actually, that looks closer to Neptune, but I don't think it is. Saturn's in the opposite. Saturn's about to go into retrograde, so it's about to reverse its direction. Neptune, very hard to see. I was trying to remember if I've ever actually seen it. I think I may have seen it once. Uranus is sitting below the Pleiades, hardly ever moves, which is fair enough, very slow across the sky. Actually hits opposition on the 24th, so it's about as bright as it's going to be for a little while. Very good opportunity to see it. 5.6, if you've got young eyes and a dark sight, you might actually be able to see it naked eye. I'm pretty sure I couldn't, but... Okay, what's happened with the club? What's happened in the news over the last month? We've bought a new toy. It's one of these absolutely incredible scopes. These are smart scopes. You don't look through an eyepiece. It builds, it knows where it is. It knows where everything is in the sky. It builds up a picture for you, and it sends it to your laptop or your iPad. It's going to be used for outreach. Really good when you've got large groups, because lots of people look at an iPad, whereas only one person can look at a time through an eyepiece. Alana took it for a test drive. It took these 3 images. The first 2 are emission nebulas in Cassiopeia. The far one on the right is the Andromeda galaxy. The bubble nebula was 11-minute exposure. Andromeda's only 3 minutes. You can see, I'm not sure you can see it from here, but if you see that on a computer screen, you can start to see the dust, the lines, the dust spirals, can't think of the right word. Lanes, thank you. What's that thing? Space is hard, words are harder. The dust lanes in Andromeda. I think these are incredible. They're really good. And hypothetically speaking, if anyone's got a husband who's got a birthday late next month and they don't know what to buy him, you could do worse. Just saying, hypothetically. Okay. We also had a Snap Hagobs meeting. I think we got less than 24 hours notice. And I think we have to accept that Richard is a weather god, because the weather was terrible. 7 o'clock, I was waiting for him to call it off because the sky was still cloudy. 8 o'clock, it was clear, and it was a really good night. I've got to say, if they're really worth it. You have to be a member to go to these for insurance purposes. They're really worth going to. Astronomy can be quite an isolated hobby, not the most sociable of hobbies, but these are very sociable. We get a lot of very good astronomers. I'm not going to name them all because I'll forget someone. I don't want to insult them. They're all only too willing to help real newbies like myself out. You learn a lot, you see a lot, and it is just a great day. I've got to say, while we were there, Lorna Pond, who took this image through what I think is a new scope. She said it was the first image she'd ever taken. She did this with her iPhone through the eyepiece, and I have never been able to get this to work, so really well done. Something I've never ever managed. Okay, so right, 3i Atlas, our interstellar visitor, which is not a UFO, totally not a UFO. Okay, that's been coming in. It's heading towards perihelion. It's brightening. It's brightening about twice the usual rate expected. I was going to say, I don't know why. I don't know why. I didn't actually find out why. It's also a bit bluer than expected, and the reason for that is it's sublimating more gas off than dust. Dust would be red, gas tends to be blue. But as luck would have it, two spacecrafts that are currently on course, Hera, which is ESA's mission to Didymorphos, the follow-up to the DART mission, the one that did the kinetic impactor on the asteroid, and the Europa Clipper, which is going to the Jovian system. Oh, I'm beginning to think there is whiskey in this. They're both going through the tail. Now, they're a long way back. They're about 8 million kilometres behind the comet, and obviously the tail is being blown by the solar wind as well. I did see that Hera is probably not got the right equipment to do any science. The Europa Clipper has. It could definitely pick up the ions coming off, but this is very fast to do. They've only got a few weeks to put together some experiments, some tests. They may not do it. China's got a reusable, two-stage reusable rocket, and they're testing it at the moment. It's its third test. They've done 2 static fire tests where they hold the rocket down and fire the engines, and it took off and landed. This is doing about 8,000 tons to low Earth orbit reusable, about 12,000 tons fully expendable, so it's really a competitor to the Falcon 9. Starship Test 11 launched, and this one hardly made the news, which tells you it was pretty successful. It certainly didn't blow up. It seems to have reached all its mission goals. They didn't recover either of the stages, but they did hover them above the ocean, so theoretically they could have. And this was the last of the version 2 Starships. They're now going to move to version 3, and that's got a much more powerful Raptor engine and a whole host of other changes. This is amazing. This is the first time I've known the next thing ever happened. Artemis 2 has had its launch date brought forward. They're looking to launch in the window that starts on the 5th of February next year. Artemis 2 is similar to the Apollo 8 mission. Apollo 8 actually orbited the moon, whereas this is just going to go round the moon and come back to Earth. Still the first time humans have visited the moon since the early 70s at the end of Apollo 17. If they don't get the 5th, the window's open for several days, and it's open several hours a day, and it comes round every couple of weeks, 3-4 weeks. So it could be 3 months away, less than 3 months away, we could see humans heading towards the moon. These are the 4 people. They were selected a couple of years ago for this mission. So that's the end of the good news. Artemis 3. Yeah, Sean Duffy has cast doubt. Sean Duffy's the acting administrator of NASA, has cast doubt on whether they'll hit the 2027 date. There's a number of problems, the most noticeable being the human landing system, which is based on Starship. Now that is very, very behind the curve, and frankly it's 18 months away. I can't see it happening. They've got a lot of major things they've got to do. They've got to do in-orbit refueling, which no one has ever done. They've got to get it certified for human launch. And then there's a whole host of problems like how will this land on the moon, because you have 0 structures or infrastructure for it to land. The regolith on the moon is notoriously harmful to just about everything. So it's very doubtful. On the positive side of things, this is really an ordeal on when will you get it. They are looking at the Blue Origin lander, and Lockheed Martin has said they can do it in 2 years. Everyone says they can do it in 2 years, just so they can get the contract. The Lunar Gateway is in doubt. The Lunar Gateway is a space station that would orbit the moon. It would act as a way station. It isn't needed for Artemis 3. I think it's only coming about Artemis 4 or 5. But the team's been furloughed due to the US government shutdown, so they've lost weeks of work. They're also highly skilled engineers. If they decide they're tired of not getting paid by the US government, they can easily get jobs in the private sector, and the team breaks up. The only other bit of possible good news is Jarek Isaacman is apparently back in the frame to be National Administrator, and that seems like it would be quite good. So on to slightly more upbeat stuff. The Astrophotography Club, who've done, even for them, an outstanding set of images this month. We're going to start with the Flying Bat Nebula. Now, the Flying Bat Nebula is part of the Cygnus Loop. It's the big supernova remains that's huge. I think it's 3 degrees across the sky, so about 6 times the width of the moon. This was taken by Steve over here. He did this on narrowband. He said it's the first time he's ever done narrowband because he usually prefers colour images. He did give me the technical information. I'm not going to read it out, partly because I have no idea what I would be saying, even more than usual. Okay, it's about 2,500 light years away, and situated in Ophius. God, I can't even read my Cepheus. I don't know where I got that from. Thank you. Okay, another supernova remain. This is taken by Martin, lovely one of Cassiopeia A. This is the youngest known supernova remains in the Milky Way, and it exploded about 340 years ago, so in the 17th century, and there were a lot of, I mean, this is after the time of Galileo probably, or possibly contemporary with him. There were a lot of keen observers of the sky. No one seems to record this. Now, it was 11,000 light years away, and there are a few examples where things were documented not in the right place, and it might be that it's just sort of a cataloguing error, but it seems to have possibly been missed. But this one's been studied a lot to see the expansion of supernovas and what happens, but it's a great image, another great image. Again, situated near Cepheus. Another one from Steve, the California Nebula. This reminds me of looking into our coal fire as a kid. Absolutely lovely nebula, 1,500 light years away. It's one of the few things in astronomy that actually looks like the name, or at least it does to me. Then he took this from his back garden. Situated in Perseus, sorry. Does somebody else want to do this? Okay, right. This is a planetary nebula, and I'll read the slide this time, just off Aquarius. Right. I really love planetary nebulas. Planetary nebulas occur when a star round about-ish the same size as our sun. As it gets older, it uses up its hydrogen, starts to burn its helium and then progressively heavier elements. This creates more heat, the star expands, outer layers start getting sent out, which is what we can see. They look magnificent. Not such good news if you happen to be on a planet orbiting the star, but you know, those are the breaks, aren't they? This is about 650 light years away from Earth. It's one of the brighter planetary nebulas close to the Earth, or one of the closer bright planetary nebulas. So, Mikhail, this is the North American nebula, an emission nebula situated in Cygnus. It's about 2,500 light years away, and about from the bottom of Central America up to Canada is about 90 light years. Steve did this one. Ooh. I tell you what, that's not showing it nearly as well as this is. This Steve took last year, but was reprocessed this year. He said for the opposition of Jupiter, which I think happens early January. We've got 3 of the Galilean moons. We've got some fantastic colours, the turbulence in the atmosphere, the red dot, and that was taken from his backyard. So another one from Mikhail. This is Saturn. This is nice. The rings are starting to open up again. I think they're sitting at about 11 degrees at the moment. They will start to tilt back a bit, just the orbital dynamics, for a few weeks before they start to open again. Lovely banding. absolutely great view of the rings. I'm afraid that isn't quite as good as the image that Nicole. I did mean to mention something else about this, and I apologise to both of the guys involved. So Martin last month mentioned the Hubble competition. They do the Hubble photography competition. Some of the astrophotographers from the group do. This one won it last month, so well done. Second place, apparently narrowly in second place, was Martin. Again, well done. And yeah, I can believe that one. I'm sorry, I forgot to mention that. Last image. This is the Rosetta Nebula. It's about, you have to look at his notes for this, it's about 130 light years across. It's a stellar nursery, about 5,000 to 6,000 light years away. Now, ZW Astro, some of you will know, only too well, are a large Chinese manufacturer of astronomical equipment. They get to see thousands of images every day, but they picked this one up on social media. It's so good and amplified it. So again, well done. Fantastic set of images across the whole board on astrophotography. This is situated, I'm going to say near Orion, Monoceros otherwise, but Orion's easier for me to spot in the sky. Okay, and that's it. Any questions? Thank you.
Right, well, good evening everyone. As most of you will know, I always try to get some big names in our program, and I was really pleased to get tonight's speaker. Garry Hunt will be familiar to many of you for his TV coverage, particularly of the Voyager missions, for which he actually got an award for ITV's presenter of the decade, and he was the only person outside the United States to be selected by NASA for work on the Voyager missions, which went out to the outer planets. He also has not only a PhD, but he's a Doctor of Science. He's a Freeman of the City of London, and he was awarded the Queen's Jubilee Medal, and not that long ago he was presented with an OBE by King Charles. Now, I have promised Garry that I will not read out all 5 pages of information that I have about him. I know he's going to give us some marvellous recollections and information about his career. So, Garry, it's over to you.
Well, thank you very much. I started, as you know, as Jerry has said, Voyager is things that most people wouldn't know about, but I didn't get into this area in the conventional way. I'm not an astronomer. I read mathematics as my first degree, and then mathematical physics. And in about 1967, when space activities were getting more and more active, I was involved. I was at Oxford at the time, doing research and working with computer systems. That was a time when instruments were being developed for meteorology. This is the real bedrock of where space activities were driven in those early days. And my colleague, Sir John Horden, and his group had developed a wonderful instrument to do remote sensing, to get the atmospheric temperature from the top of the atmosphere to the ground as input for weather forecasting. You may obviously have comments about how weather forecasting operates. But one of the problems they had was clouds get in the way, and they didn't know how to handle their data and deal with the clouds. And it was through that and my mathematical background that I was able to get involved in space activities, which led to being invited by the chief scientist of NASA to go to JPL, and everything else followed. But Voyager is something special. I remember vividly I was then back in the UK working for the Meteorological Office. I got this telex, for those that can remember these ancient means of communication, inviting me to, in fact, selecting me to be on a member of the Voyager imaging team for the mission. Now, Voyager had its 10 instruments. Imaging was different. They said, yes, we're going to have a television system on it, but you've got to actually make it. We're going to put a team together. And we weren't astronomers. If you remember, it was Brad Smith, who was the team leader, who was an astronomer. It was Carl Sagan, and it was Larry Soderblom, who was a geologist. And now I'm a physicist by this time. And therefore, it was people who were involved in a broader spectrum of things than we've had before. And we were that basic team that had to deal with the challenges that set before us. Now, just put the dates in your mind. It was 5 years we had. In 1972, we were selected, and we launched in 1977. 5 years, of course, was the time it took to rebuild the Notre Dame. Can you imagine what we could have done with HS2 in 5 years? You put us in control? My goodness. We could not be a second late. This is an opportunity once every 76 years to actually have a mission which could fly by Jupiter, Saturn, and onwards to Uranus and Neptune. So we had a time scale to work to, and in that time scale, we had to develop instruments, and in particular the television system. But one of the first thing was, as I said, there was a pathway. I remember vividly getting the documentation coming to me, and these are pre-computer days. Everything was paper. I would be back in the UK receiving these great bundles of documents coming and having to go every month to California. I was a California commuter. And it said to me, "You're a gambler." Well, I may have been to school very close to the Epsom Downs on the race course, but I'm certainly not a gambler. But we had to choose our path. And we had a choice of 10,000 possibilities. And what we were uniquely doing was actually making use of this rare alignment of the planets, which are virtually in a straight line, where we could swing by Jupiter, be deflected onto Saturn, and hopefully thereafter. It was difficult. I had previously, during my time at JPL, been working on Grand Tour. That was the mission where originally we were planning to go to Jupiter, Saturn, Uranus, Neptune, Jupiter, Saturn, Pluto. But that was deemed far too expensive, and therefore the president at the time, Tricky Dick, President Nixon, decided only to fund the mission out as far as to Jupiter and Saturn, and hence the mission actually became known as Mariner Jupiter Saturn. That was as much as we could do. That's what they thought as much as we can do, and as you'll understand, we can do more. We knew so little. And this is where you, as amateur astronomers, have really, really made everything possible. The BAA, and in the BAA, there's wonderful sections on Jupiter and Saturn, which many of you will probably be involved in. There's the famous book by Peake, the work by Bill Fox and others, the work by Alexander, which catalogued all the past observations and document information known about Jupiter and Saturn. They were the documents that we read in enormous detail and used as a basis of working out what we would like to see. We knew nothing about the satellites. We thought Io was going to be dead as a dodo. We were wrong, weren't we? And we thought the activity would be out on Callisto and Ganymede. So we had little knowledge, but if you think about it, there was then a challenge. You're on a spacecraft, a 3-axis spacecraft, and in planning the observations to be made, there was a competition. Looking at the weather systems, that's what I was primarily interested in. I want to see how things develop over time. And I've been wanting to actually study particular features, and therefore the time element is key. My colleagues, Larry Soderblom and others, are interested in the geology, and they want a map at different, much higher resolutions. So it's a competition of where we should be pointing the camera. One of the major aspects of this mission, which made it such a success, was the way in which it was set up, being bore-sighted. You had the television cameras, you had the infrared radiometer, you had the photopolarimeter, and you had the UV spectrometer, all of which were bore-sighted. In other words, they look at the same place at different wavelengths throughout the spectrum. And this enabled us to use the information and be able to turn into a physical understanding of what we were seeing. So the observations had to be carefully planned, but we still had no idea, could we really get there? Space is dangerous, and the asteroid belt and going through the asteroid area was something we didn't know. Was it as dangerous as trying to cross Oxford Street in the rush hour, or was it easy? We had the Pioneer spacecraft ahead of us. That obviously gave us a clue that things could get through, but that also gave us a jolt as well, because suddenly we learned that Jupiter had an incredibly powerful magnetic field, far more powerful than we anticipated, and therefore the instrumentation we had to build there had to be really hardened to protect it, to make sure it could survive. So over those 5 years, we gradually built the instrument downstairs in my study, which is the background you can see now. In fact, in the bookcase behind me, there is a Vidicom, which is one of the, I think, the last 2 or 3 Vidicoms of that era that actually exists. I managed to slip one out of JPL. It was the classical sort of television way of going about it. We had 2 cameras, wide angle, narrow angle, and we had the classical filter wheel and our choice of filters to put in there. And that is a very interesting setup of how do you choose those filters. Remember, you want color pictures, so we did the classical primary colors. And then just about that time, Professor Neugenberger at Caltech had made some observations, and when they were sure they weren't looking at the Los Angeles streetlights, they confirmed that there was perhaps it was sodium around the area of Jupiter, around Io, and we needed to have a filter of that sort on board. Obviously, we needed a UV filter, and the question was, should we have them? Where should they go? This was a battle of the ages. The elders, Merck Davies, Brad Smith, Carl Sagan, and others, who had obviously far more experience than we did at that stage, decided we couldn't dare take a risk by having those things on board, because if the filter wheel got stuck, can you imagine just looking through the entire objects that we could be discovering through one of these wretched filters? Whereas we, the youngsters, I was then in my 30s, having been selected in my 20s, we were all gung-ho for it. And there was a battle. It really was a lively debate. Perhaps not quite as lively as PMQ is at the moment, and we won. So we did actually put a range of filters on that enabled us to look through the range of wavelengths, which included methane and sodium as well. So in that 5-year period, tremendous amount of work. And these are the people who deserve the credit. Not us, the scientists, it's the engineers. They are the people who have built a spacecraft, which we will very soon be celebrating the 50th anniversary of its launch. It is still working today. And as I've discussed with Jerry many times, I am very concerned whether in the new world that we're moving towards, we will ever see spacecraft with quite that ability to withstand all the challenges that it has and to be lasting so long. So as we moved towards 1977, we had the spacecraft, it was prepared, it could not power itself from the sun, it had to take its own power, so it was actually like a nuclear power station with RTGs on board. We never actually asked ourselves, what would happen if it crashed in Florida, it would have been a nuclear disaster of the highest order. And quite honestly, we should have been a little more careful about that. So, but we had that, and that was the key to keeping us going. We had the other instruments to look at the magnetosphere, the charged particles, and of course, the ability to communicate back to Earth. Voyager 2 was the first one launched because we had planned the mission, and Titan was a key. Let's go back to why we were looking at these objects. We wanted to understand the origin of the solar system. We want to understand the origin of the Earth. We want to understand and find out whether there's a possibility of life somewhere in the solar system. Keep that in mind, because they were the drivers for this mission in 1972. I say think it in mind because now, in 2025, still haven't answered those questions, but they were a good reason to keep us, to drive us off in our mind. We launched on Voyager 2 first because of the way it was going to take its path in such a way that Voyager 1 could see Titan first and Voyager 2 could be adjusted to look at it better just a short time behind it. All did not go well. I remember vividly being at that launch, feeling very, very happy as I saw it rise through into the sky, and then suddenly be told we have a problem. And the problem was that it hadn't opened up properly, and therefore it hadn't locked in position. So as it moved on its trajectory, it would be flapping around. And the only way we got over that was use classic angular momentum, spun the spacecraft around, and it locked up. And changes were made in time for the second launch in September of Voyager 1. Problems also with the communication systems as well. It was partially deaf for a little while. But the spacecraft moved on. You've seen the pictures. And that is where we can put a really important stake in the ground and say, this is where space exploration of the sort that we're all accustomed to has changed so dramatically. Because what we were doing is that we were using our computer systems to not just look at the pictures. A picture's worth 1,000 words, but we could actually remember each pixel, each picture element is a radiance. Properly calibrated, we can actually then do physical studies. We developed in the UK, from my group then at UCL, we developed the software to track the clouds, to get the wind speeds of Jupiter's incredibly dynamic weather systems, gaining the information about how the storms were developing and interacting in a manner we've never seen before. These were very, very important breakthroughs on computer systems, not like the old batch systems we all had of those days. Remember punch cards and all those things? This was done on an interactive system, which my team had actually developed in the UK. I remember having one of those eureka moments we all have, walking back from a meeting in college, and I was walking across Gordon Square, and suddenly it came to me how this thing could work. I'm not a technical person able to do that sort of thing. That's for others. But I was able to put together a team that developed a really sophisticated system that did other factors as well. I'm sitting here talking to you over Zoom. I have various apps and other techniques to use. I've seen the fabulous pictures you have just shown tonight. Wow, they really are super. And you can analyze those in a manner which is way, way, way beyond what we could do in those days. We, of course, learnt so much about Jupiter. Always a surprise. I remember vividly coming back from dinner one night with my colleagues, and the phone rang, and the voice of one of the engineers on the floor above us, and she said, "What's wrong with your pictures? This one's got a slight bump in it." That was not a bump. That was a volcano. That was Io. and suddenly a major discovery was made. If I think of one of the early aspects of why Voyager has been so successful is our interaction with the press. Right from the very beginning, we realized that we had a fantastic mission. We had an opportunity to push back the boundaries, and indeed we have so many books on astronomy rewritten from the results that we have gained. And therefore, our relationship to the press was very, very significant. And in the von Karman auditorium, it was packed with every TV company that you can possibly imagine was there. And every morning there will be a press conference and we relay the the results that we had discovered. And this was built around about 10 days just before, through the encounter, and just afterwards. Jupiter, and obviously the satellites changed our life. I've just heard you talking about Europa Clipper. I talked to the JPL director of that quite regularly. And Europa was a surprise for us. Indeed, the Galilean satellites were a surprise. We got them the wrong way round. Io was incredibly exciting. Who would expect all those volcanoes? Europa had these funny lines over it. We didn't know what they were. And it's only the subsequent missions that have helped us to understand them. And similarly, the strange structures on Ganymede and the more expected crater structures that we see on Callisto. Everyone was a surprise, and we're still, and this is what thrills me so much, even now in 2025, people are writing papers analyzing and interpreting more precisely what we saw over 40 years ago. After Jupiter, onto Saturn, again, amazing discoveries, the observations of Titan. Nixon thought that's the end, not us. We're smarter than that, aren't we? As good scientists, we had, in selecting our trajectories, we had already planned that if we got that one right, we could go on to Uranus and Neptune, but we never owned up to that. Until we were getting up towards Saturn and Titan looked example, and we said, we're going on to Uranus and Neptune. And we had to go back. We were being Ed Stone and myself and others to get extra funds. But we were set an immediate comment, as you always get from these political types. Well, oh, you can't do that. You haven't got enough fuel on board, have you? Oh, yes, you have, because we had already planned very carefully that this was a definite possibility. And before Voyager had taken off, it was full to the gunnels with hydrazine, and it could carry on. So it was all set to go forth and onto Uranus and Neptune, while Voyager 1 had done its path, was climbing on a different orbit out of our solar system. As I said quite early on, it is the engineers, the spacecraft engineers, who deserve the credit, and they certainly did, because you will remember that during that time, and I was doing mission discussions in the media literally all the time about Jupiter and Saturn and such like, when suddenly we had a problem. The interactions with the press can be a double-edged sword. We got a call one evening. It always happens in the evening, doesn't it? And it said, why are you guys, because we had pictures going all the way around JPL, why are you guys showing black sky? And of course, our immediate reaction was to say, no, that's not black sky. We're just calibrating the cameras. Put the phone down and said, what the devil's happened? And of course, as you remember, the scan platform had jammed. Jammed because the alleged lubricant, if I can use that word, in these frozen conditions of the outer solar system, had got into a stage that it simply couldn't move at different speeds. So what do? You can't call AA relay and say, we need help, guys, come and help us. We had to work it out. And the secret is there is always the backup. There was another absolutely completed spacecraft available in JPL to which they could try loads of tests. And they found that they could actually move the scan platform at a different speed and operate in a different manner. And that had to be recommanded and operate and repaired. That was an example not just of the engineering, but the way in which the people were used. Jerry has alluded to my career as a scientist. Well, in fact, my career in business is actually far longer. I've been actually a businessman and continue even at my great age involved in that now. And I was able to transfer the skills that I have, the management of people, and some of them I've learned from the space program into that world. One of which is we wanted the best people to be available to make the best decisions. People came to meetings not because they wore the badge saying I'm the king, or I'm the chief person here, etc., etc. It's the value you bring to the meeting. And that was the way we mixed the scientists, the engineers, the communicators, the software developers all together, and were able to develop a way forward and get us out of this mess. And we did. The way we managed people was very, very important, and certainly a wonderful skill to actually learn. The mission has gone on to Uranus. Think of the discoveries there. What a surprise, finding a magnetic field totally offset, active, an extraordinary geology we find around Uranus, and then on to Neptune, even at this distant stage, where we found the fastest winds in the solar system, which are not properly explained. I've offered my theory, and I shouldn't be doing that as somebody who's not been teaching atmospheric physics for a long while, but I think seem to be right. This is a big difference between the depths of the atmosphere. Jupiter has a massively deep atmosphere, and I'm sure that the atmosphere of Neptune is not as deep, and it's led to these very, very fast winds. And look at Triton and geysers. The question we asked, when you think back to when we started in 1972, we were expecting things to be, there may be some interesting geology, but we weren't going to expect so active a geology as we have found then. So in terms of the Voyager mission alone, what we have seen up to that stage was the most incredible difference between the major planets, amazing geology. And then, as we left Neptune, we took what I think is the most important mission of the entire, most important picture of the entire mission, the blue dot. That picture, looking back at the entire solar system, which shows the Earth to be no more than a tiny speck amongst the stars. It is our island home. It's the only place in which we are able to live. Titan is not like anywhere we could suddenly move off to. Our isolation was emphasized. I regularly have asked my views and thoughts about climate change, which is part of my other aspect of science research and such like, as a predictor of climate change. And I regularly show this picture as to say, this indicates why we cannot afford to screw up the Earth so well as we're doing at the moment. That the Earth is the only place that we have got. Voyager continues. It's got through the heliopause. It's now on its path out towards the Oort cloud. Didn't get through there very easily. It kept coming and going and coming and going. But again, it showed something that quite surprised us. Even at that distance, the impact of the sun and solar storms are being felt in the depths of the solar system. We never anticipated that in that manner. And as the spacecraft now moves out of our solar influence thereafter, it's now moving on to other worlds. It's interesting to reflect. You've been talking about the wonderful astronomical observations you've been making and the hundreds of light years away this is and various other places. Voyager has actually just reached one light day, not a light year, one light day from the Earth. It really does put your observations in perspective. Voyager is a landmark, and subsequently we've had Galileo, we've had Cassini, we've got Europa Clipper, we've got the need for other missions coming up as well. But the point I want to move on to now, just to come reflect and come to allow Jerry to ask loads more questions, this is an incredibly strange period in the world of space activities. It is a transition point, a time when we transition from space exploration to space exploitation. The difference is quite fundamental, and it has enormous implications. It's being driven not by the US alone, it's being driven by other nations. I entered the space program. There were two space nations as such, United States and Russia. Now there are 80 countries with space agencies. There are major drivers. The US to a reasonable degree, China very much there, India, UAE, ESA, which again has got massively exciting programs, and of course Russia and its defense programs. The focus now is how do you pay for these missions? Voyager was, well, I wouldn't say expensive, because $800 million. That's about 25 cents per American per year for the time of the mission, which is not very much. But now there isn't that money. You can see what is happening in the US with the tremendous cutbacks by Trump on the US space activities and NASA. The effect upon JPL has been pretty serious, and I can elaborate as Jerry wants me to later on. It is very serious. And I think that this will have an enormous effect upon how America goes forth. Hearing what your discussions of Artemis, I love to hear your optimism. I think you're incredibly optimistic. It's going to be driven by how long Trump feels he's in office, and I'm afraid all hell could break out in the meantime. China, on the other hand, has enormous budgets and has got a well-designed program. But where the exploitation aspect is making it different is that we have got to be in the state of who funds it? I'm an investor. Am I going to put money into a mission which lasts 30 years? Absolutely no. I would be interested if it's 30 months because I want a return on my money. Therefore, missions of a short duration are going to be much more attractive for support than those of the longer duration. So the exploration types are going to be few and far between, supported by countries with deep pockets, China, perhaps European Space Agency, perhaps India and other collaborations. The US would love to, but the knock-on effect of the cutbacks by Trump has been catastrophic for the loss of staff. JPL have lost an enormous amount of talented people. So this is where people's attention is turning to the moon and Mars. Why are they turning to the moon? Well, modern technology, not just my iPad, my iPhones and other devices, my watch and everything else. Yes, we use the rare earth metals are key for that, and they may be things that we could exploit. But if we start having missions aiming at that, you just cannot go and land on it and stick a flag in there and say, this is mine. The law does not allow it. There is a 1967 space treaty. It says you cannot do this, guys. So we're in a very tricky state that if the US get there and China want to get there, and even the threats of putting nuclear power plants up there, to which the defense people will be getting very cross. If you go and talk to Space Command in the UK and other people, they will be raising severe concern, as they already have. You can see the problems that they face. Turning slightly to another direction, of course, there is the fascination of going to Mars. We've discussed this many, many times, all of us. I've sat down many times with Arthur C. Clarke, and times when we used to meet when I was working in Sri Lanka and discuss this. And there's a delight to do so. Personally, with the current state of our technology and our launch capabilities, I think humans to Mars are a bit far-fetched. I would not be supportive of them. I'm much more supportive of robotics. It could well happen. Once we get improved technology, we can get there faster. The medical problems are very, very serious. Real medics have actually proven of the dangers of doing so. It will happen. I was actually thinking about this more today before coming to talk to you. I can imagine going up to Christopher Columbus or Magellan and saying, I shouldn't sail a ship over there and disappear and go to where the sky meets the sea and you don't know what's happening, you'll disappear. That would never work. And this is the same sort of conversation we're having vis-a-vis Mars. Someone will do it, but the dangers, the implications are serious. But the legal side needs to be looked at very carefully. Space diplomacy is very, very important. But really, a factor which worries me thinking about yourselves is all the activity in space. This year, China has launched 72 satellites in orbit. You've got the Starlink group, you've got the Kuiper group of hundreds of satellites. I've just written a paper. I'm prepared to say who it's. I'm written it for the Foreign Office at their invitation. I can assure you that writing for diplomats, lawyers, and civil servants isn't exactly easy. However, it will be written. It will appear soon, and Jerry will have a copy. But one of the things I showed in there was a picture I got from a colleague of mine at Lowell Observatory, who, like you, was taking observations of distant galaxies, and it's got more lines on it than are railway lines at Clapham Junction. Why? It's all the Starlink satellites just happen to be going through at that particular time. The impact upon astronomy is very, very serious. And there's a great clash now between science and the other world of the commercial sector. The dangers are immense. Collisions are very easy. We've just had one. The Chinese have just had a major collision and cannot get their guys down. They've had to stay there in orbit. There have been even worse ones. Just look around your room and think of 15 meters. Not far from one side to the other, is it? Well, can you imagine that last year, two massive spacecraft were hurtling along towards each other over 20,000 miles an hour and passed within that distance? Frightening thought, isn't it? The amount of clutter up there is terrifying. If you look at a picture of space in 1972 and space as it is now, you cannot believe it. There was actually nothing there in the 70s. Now it's so cluttered, we've got to clean it up, because having the traditional orbits where geostationary and other ones are, having the LEO orbits, it's so complicated that things are falling out of the sky. We've got to clean up before we can go any further. Not just the Earth, but also for the Moon and Mars, if there are things that we can look at. So that really is an indication of some of the things that I've been involved in, and my career has taken me through Earth satellites, Earth climate satellites. I was involved with Viking, the landing mission, Voyager, which was and it still is because I'm still always I'm involved with Voyager still, yeah, interact with them. The mission are beyond all missions, and an idea of its lifetime. When I wrote my proposal for Voyager, uh, my children were about my daughters before my son was born. My daughter, elder daughter, was about 4.5, 5. When it got to Neptune, she was at Cambridge finishing her PhD and came to work for me. I think we'll soon be submitting for some of these longer missions our indication of the age of our children or such like, so they can carry on the activities. These missions go on and on and on. I'm frequently asked, did you actually think Voyager would last forever? I'll tell you quite honestly, we never thought it wouldn't. Jerry, over to you.
And early on about how the media were so supportive of the Voyager missions, and a major reason for that is the fact that people such as yourself were able to explain the missions to the public, and to do so not only with the knowledge, but do so in a way that the public could understand, and to make it all engaging. And that's a great thing, because I've been to so many events where someone has given a paper about something and they may be an expert in it, but really they have no way in how to communicate that information to the public, and that's certainly something that you're a master of. So yes,
Can I just add one thing? One of the things that I always think of, I've worked a lot with James Van Allen of the Van Allen belts, and he and the other people studied the magnetospheres. And just to add to your comment, they were always known to us as the morticians, because every time they came up and spoke about these what they'd done, and everybody else nodded off to sleep. But we had to get our message across, and it was fun. And one of the funniest ones, or one of the difficult ones to do was I was chairing a meeting one afternoon, and I said, "I'm sorry, this meeting's going to finish quickly at 4:30." They said, "Why?" I said, "I have to do a rehearsal." "Where are you rehearsing?" said my board, because I was. And I said, "Well, I'm appearing at the London Palladium." That was where I got my award from ITN, and I was interviewed by Cilla Black. Well, spelling may not be her forte. She could do other wonderful things, because I was reading her teleprompt. I never use teleprompt, as you probably noticed tonight. But she was talking about my work at NASA. Well, NASA in Liverpudlian is spelled Nassau. Keep it in mind.
time there were some students manning a NASA display, and with their accents they were pronouncing it Nassau, and one lady came to them and said, it's so great that a small place like NASA has such a fantastic space program, and I bet you did it without any American help as well. Well, firstly, to people here at the university, does anybody have any questions that they would like to ask? Hands, come on. Yes. And meanwhile, those of you on Zoom, please put your questions into the chat and we'll take them as well.
Come back and see you.
Information science from both the Voyager spacecrafts, and how long will NASA have the appetite for it?
Did you say the first bit again?
How long will we continue to receive electronic signals and science from the two Voyager spacecrafts before they run out of energy?
Well, well, it's going to run out of money rather than run out of anything else. The we do have funding. It has been cut back by about 30% by the swish of the Trump sword, but and it will be funded certainly until its 50th birthday. It will go on being able to be received at about 2035. The limitation is not the fact that it cannot communicate. Is that it's so weak. It will not be possible with our even our ground the way we've worked our ground-based instruments to receive it. The Goldstone instruments were enlarged between Saturn and Uranus in order to get the observations there. So certainly you're going to get it for the next 2 years. After that, sadly, we probably won't be able to hear it. We will run out of money. Have I lost you? Am I not hearing you, Jerry?
And is, if I've got this right, is there an overriding?
Is there an overarching, well, not management, but
No,
some overarching
but
body that-
is there communication and between them all, or are they independent?
Yeah,
Basically,
is there some sort of overarching management of them? Not exactly management, but or are they all independent of each other? And if they are independent, is there much duplication that goes on?
these missions from various space agencies independent, or is there cooperation? Let's say between.
I think the important thing here about space activities is that they actually are a fantastic way of developing cooperation between nations. NASA and ESA have worked together, I'm sure, and you obviously the UK, which sits involved in ESA. Yes, all these nations will work together. How China fits into this, I don't know. India certainly has links to the US. India has links to the UK. So cooperation is very, very important. And in fact, this is one of the concerns that ESA had, as NASA has had this great slash to their budget. They've lost lots of missions. Obviously, ESA had to sharpen up what it was going to focus on, because many of these things simply cannot be done alone. And their missions are getting so expensive, individual nations could not actually do them alone. So cooperation between nations is very, very important. And this is one of the things that comes out of it.
Right, thank you. Any other questions from in the room? We have a couple of comments on Zoom saying how marvellous your presentation has been, but we don't have any other questions, which is, yes, okay, so we do have one here. And at the back first.
It was brilliant presentation. Thank you for that. Thinking about the thinking about the missions that are in the pipeline that are more than just on the drawing board that we're going ahead with, which one or two sort of really perk your interest? What do you find the most exciting missions we can expect in the next 10, 20 years?
Well, certainly, there's the outer planets is just sitting there saying there's so much to learn. Europa Clippers a start. Enceladus has got to be terribly, terribly exciting. The thoughts of Titan and what they can do there. I think looking back just to show what my follow-on thoughts. I thought one of the most incredible things about Mars was the helicopter. That was just stunning. How the devil do you fly a helicopter when it was 6 millibar surface pressure? Well, on Titan, you're probably going to have a helicopter. You're going to have possibly something that can deal with the liquid that could possibly be on the surface as well. So those missions are going to be marvelous, exciting. Whether we can go further to Uranus and Neptune, I don't know. The timescales we're talking about, if you're planning missions now for the 2030s, you're talking 2050s. I'm afraid I will be with Patrick Moore watching it somewhere else by then, I'm sure. But the gaps are getting enormous. We were just so jolly lucky to have the grand tour as it was, the Voyager missions at that time scale. That's never going to happen. And one thing I can also add, it's pretty frightening when you watch those launches take place, not for the launch itself, knowing if it goes wrong, that's the end of your career. I've been lucky.
Before we come to the other question in the room, there's one online saying, can you give any tips on communicating science?
Oh gosh, yes. It goes back very simply to Michael Faraday. I remember when I was invited to give a Royal Institution lecture and ultimately a Royal Institution Christmas lectures. Very simple. Have a well-defined introduction, a well-defined ending, and just a very careful structure. Don't do the death by PowerPoint. But I always remember, I often used to show to people when I was doing work in companies how not to do it. And one of which is Dilbert says, on slide 946, you can see, well, that's what people do. Have a minimum number of slides to do it. So a very careful introduction, and it's ABA. That's what we teach people on television. You tell them, the people, you explain what the problem is about, and then you summarize again at the end. Very simply an ABA principle. But certainly, if you're going to talk for 20 minutes, you do not have any more than 8, at most 10 pictures. Don't try and stuff them in. Tonight, I have literally not prepared slides or thought. I just talk. And I was lucky, perhaps that's one of the things that I actually have. But working with Patrick was always fun because he and I had had a schoolboy style in the way we operated, and we knew how to balance things between each other and to be able to, working together to keep it like a game of tennis, keep the rally going. But quite simply, it is a well-defined introduction, elaborate on it, and then your end is to summarize again what you set out to do. Keep it simple, stupid, as the Australians always say.
Okay, one other question from in the room.
Yeah, I hope this isn't a silly question. I read recently about the Voyager 2 leaving the solar system, and I was just wondering how that's changed the communication, because apparently the laws are very different when you leave the solar system. So I was just wondering if
but one of the issues that did break out was that you probably remember there was a time when just after it went through the heliopause, that we were not getting signals from Voyager. It somehow had the antenna it's got itself turned so it wasn't directly turning to the Earth. Now the question was, how do we overcome that problem? And this is where age actually won. So those of you in the audience who wrote computer programs like me in the 60s and 70s, you remember assembler code. Yes, you'll remember that. You'll remember Fortran and all those wonderful things. Well, JPL had to go and find some people who could write assembler, because all the codes that were written in those ancient days, that was what was used. and they didn't have anybody on lab. But they had some people who had just retired who still used assembler. So Voyager was saved by retirees who came back, rewrote the software, was able to get the spacecraft to actually perform the way it should have done, which meant reorganizing the computer software. But the laws of physics haven't changed. They're the same as before. The problem is the spacecraft is slowly moving on. Well, it's not slowly moving on. It's moving on at 20 odd thousand miles an hour. But remember, one light day away doesn't sound very far, does it?
We have some questions from Zoom which continue the idea of communicating at a distance. One asked, could you set up a relay mission which could retransmit the weak signals from Voyager? And if so, what would the problems be?
Well, we wouldn't do it for Voyager now, but no, that's a very important idea, and I think these are things that we should look at for the in the future. It's rather like an add-on to one of the drivers for the Starlink and some of the other terrestrial satellites is to put the internet up into space and to over the globe. But yes, we can do that. Use spacecraft in that way, but it will require an enormously careful planning, positioning of these things in order to actually to perform it. Theoretically, it is doable, and I'm sure there will be missions, perhaps not so much for the outer planets, but for the inner planets, where things like this may actually be done. Quite honestly, those of you who were working in the 60s and 70s, think back to how we operated then and what we can do now. It's absolutely mind-blowing. So it's very difficult to say, no, you can't do it. The answer is, I'm open for any opportunity. I think everything is possible. We have to carefully plan it and make sure it's cost effective in the way we go forth. But the challenge is going to be not the technology, but it's access to the materials we need to make the technology. And that is going to be quite a battleground of all of these aspects for the future. And quite honestly, the only country in the world that can actually mine and resource the rare earth materials is China. They've already done it. They're doing it in great deal. America wants to do it, but they do not control the supply chain. So suddenly there is a word called geopolitics, which has now moved into the space discussions. And I'm afraid China is the one which is dominating it. And this is something which I'm afraid the Americans don't really understand. And that's why I work so closely with the Foreign Office, with our ambassadors, with our military and such like now, because we see these issues as the real drivers for the future.
Are there any particular results that could be gained from Voyager within, say, the next few years?
Well, I'm glad you raised that, because one of the things that excites me so much, and one of the things which is very an important step forward from where we were when we had missions like Voyager, the data belonged to us, the space experimenters, for 3 months. We were the only people to have it. Now it's available to everybody. You can get it online. Anybody can work with it, which is fantastic. People are still working with Voyager data, particularly the satellite observations. So I think you're going to find geological information particularly coming out of it. You're going to get Voyager compared with perhaps the Space Telescope and the James Webb Telescope particularly as a means of looking at how the weather systems have changed. And in fact, one of the things that really I find really quite exciting is the James Webb Telescope is throwing so many opportunities up. We have to balance how do we best use that compared with actually needing to go there and have a flyby, because the James Webb is certainly a lot cheaper way of doing things than actually having a mission that goes to the outer planets. So yes, the data is there. Look at it, analyze it. You can do it tonight. You can log on and get a hold of some of the data, and who knows, you may see something we haven't spotted. Certainly the geological work is really quite fascinating for the future. So who knows what can go on. Anything is possible. There was one quite recently by some colleagues of mine that I know in Oxford who were complaining, or not really complaining. They mentioned that the colours on Neptune weren't quite as blue as they ought to be. Not really surprising. Look at our pretty primitive imaging system we have. We're not going to sit there and shade it in with a blue pen. But no, if we'd have got better filter structure on our cameras, perhaps our colours would have been more realistic. But no, so there is work going on all the time, and this to me is fascinating. There were, was it 85,000 pictures? That's a hell of a lot, isn't it? I was actually recently asked by JPL, would I be interested in selecting the best pictures from Voyager? And I said, oh my God, that's just about impossible, isn't it? I did offer them the opportunity of doing, rather like classic FM, the top 100, and allow everybody to choose their favourite 5. And in fact, you may want to do that as a competition yourselves, and say, what are my favourite 5 pictures from Voyager? Well, certainly Io will be in there. Certainly Europa will be in there. The close-ups of the red spot and its interactions have got to be there, as well as then going right the way out to the geysers that we saw later on. So, yeah, well, that's an interesting challenge, Jerry. You could have a little competition on that one.
We'll see about that then. Here's a question which is rather different from the others. If you had the chance to change one item on Voyager, what would it be?
Holy mackerel. I think what would it be? Well, I think if I would change, it would certainly the instrumentation, I think, will be the only thing I would improve. If I could improve the instrumentation a little bit, the imaging side, if we have better filters, if the radiometry went to longer wavelengths, that would be a difference. When I look at the computers, I look at my phone or look at my watch and think, good God, the power in that is far in excess of the computer system we had on board. Voyager would benefit particularly from modern technology. You think we were flying, one of the requirements that we had was reliability. And that was one of our secrets. We had a lot of backups, and our computer systems wasn't there because it was the latest, but it was there because it was a Mariner mission type computer system, and it was reliable, and that's what we wanted. So I think upgrading some of the elements of technology would be absolutely the obvious things to actually do, but little else, quite honestly. We had the right balance of instruments, with no question about it.
One last question online. What do you see as the most likely commercial opportunities which may attract private investors other than the development of spacecraft? And what timescale would they accept for commercial returns?
Well, the first thing is you may not be aware that Britain is the leader in space insurance. If you go to the City of London, Lloyd's and the insurance companies are the world's leaders in that. So that is a massive, piece of income for this country. What are the areas who've got to be? Well, I think the first ways in which we can clean up space in a continuous manner is a major opportunity to be done. What do we want to return? We want a return. We're talking perhaps a few years, a year or so, but certainly not decades. But cleaning up space, I think, is the major thing that we're looking at to make sure things can get at. And then, of course, it's from a commercial point of view, away from the building space and the instrumentation side, it's the exploitation of what you can get when you get there. So if we can get spacecraft to go to these other planets, and we can do space mining, which I'm not actually in favor of, then that is obviously something which will attract investors in a big way. But I'm glad somebody has raised that question, because one of the things I'm working hard at the moment, and have been for some time, is to try to change the style in which we do things in this country. I've worked in the United Kingdom and I've worked in the United States, and the difference in culture is really quite tremendous. Americans, if you make a mistake when you're doing your work in America, it's not a question of wrist slap and a red card and off on your bike, off you go. It's what have you done? What have you learned? And I think that is important. Whereas in this country, if you make a mistake and fail, that's it. And I think we've got to adopt a different attitude in this, and we've got to really be prepared to take a risk. Our investors in this country do not take risks in the same way as Americans, and that's why they will always be ahead of us. But I think there are opportunities. Timescales, we've got to measure in months and a few years, certainly not in decades, or in the case of Voyager, half a century.
Right, we have one last question from here in the room.
Okay, and I think this has to be the last one.
Yeah.
So.
Sorry, it sounds like a silly question. Is there some sort of an air traffic control system for these satellites at all?
Oh yes, there is a traffic control system. It's not traffic lights, because in fact, when Voyager is flying, it's not the only person that's using the deep space network. Think of all the other spacecraft that are up there that are being monitored, and who are sending back signals in order to carry out their particular tasks. So there is a flight control setup in JPL which actually controls them all, and they are pre-assigned their particular time slots in order to communicate. They've also got to link up, not just Goldstone on its own, because there is part of the ground space network is in Madrid. There's another one in Australia, and there's another link in Japan. And I do remember going to the one in Australia with my friend Werner Sumi, and they discovered we were Voyager scientists. And honestly, we were really treated royally. It was quite incredible. I was quite embarrassed, but they were delighted that people involved in this mission actually did exist and they could actually see them. But the role they have played was quite fundamental. But Goldstone, which is just outside Barstow in the Mojave Desert in California, is the key center. That's where all its is set down. It's controlled, and obviously they can't compete for the facilities at the same time, because they would just annihilate each other. And that's why they have to be controlled when they can download. And that's why we have tape recorders on board. And that's another weak link in our system, that the tape recorder could malfunction. That was another danger. It didn't, but that they can record the data until the spacecraft is in a position to download. So all of these things were carefully planned in advance, and that's why they can handle so many missions at once. Voyager wasn't the only one flying at that time. There was a whole lot of others.
I'm sure some of you will have seen the film The Dish, which is about the radio telescope at Parkes in Australia. and how they received the transmissions from Apollo 11. It's a great film, which I recommend. Garry, thank you so much for this evening. It's been thoroughly enjoyable and as well as informative. As I said at the beginning, I've been very, very pleased to have been able to get your agreement to talk to us this evening. I'm sure those of us here in the university and on Zoom, a total of around 60 of us this evening, which is very good, have all enjoyed it, and we'd like to show our appreciation to you.
Thank you very much indeed, Garry. I just repeat how privileged we all are to have had such a wonderful talk this evening. So clear, full of lovely information. I can see by the smiles on the faces in the audience here, that was terrific. So just a few announcements, 4 if you want to count down on the way out. The first one is on the 26th of November. Haggas, our astrophotography group, have got Graham Devonish coming along to join them via Zoom. His presentation is called Keep Looking Up. All members are welcome, and that is going to be in room 1A161. I emphasise the first 1 because that means it's upstairs. It's not this room, it's upstairs. As you come through the main doors, go up the staircase and you'll find the group up there. 26th of November. On the 28th of November, 2 days later, it's the next Bayfordbury Open Evening. So free entrance for us if you come along with a telescope, or if you want to man the stall indoors and promote the club, we can get you in for nothing. Of course you can have a little look around as well, and that's on the 28th. Just to entice you a little bit more, those of you indoors, we hope we can demonstrate our new virtual reality sets that we've got there, and those of you outdoors, we'll be showing you the C-Star telescope we saw earlier. Our observation group, HAGOBS, they will announce their next opportunity to grab your scopes and join us at Bramfield Village. Can't give you a date for that because we need to know what the weather's up to, but like you heard earlier, it can be very short notice. So it looked as if it was going to be rained off last time, but as John mentioned, the rain gods did their bit and disappeared. And then finally, the last meeting, the next meeting, the last meeting of the year, is going to be here on December the 10th. And we've got another slight change or two to tell you about there. First of all, if you've got one of the old programmes, there's a change to who's giving the talk. We've got Greg Smye-Rumsby coming along. He was the chap we had to cancel in October, so he's coming to give us the talk on the history of longitude at Greenwich. And the other change is it's not going to be in this room. It's going to be in the one next door, because there's something else booked for this one. You'll just come in the same way and you'll see where to go. That about winds it up. I would like to say a very special thank you. Perhaps you could catch me afterwards. A very special thank you to all the team who've made tonight possible. Very special thank you to the technical team, because you've really pulled out the stops there. I know you had quite a few challenges. And obviously thank you to Jerry for organising such a great speaker. And of course to Tony, who's sitting outside there, and I think he's overcome his problems with the tickets. So thank you very much indeed for all of you for coming along. I hope you have a safe journey home, and I look forward to seeing you at our next meeting. Thank you and good night.